two temperatures, 700 degrees Celsius and 800 degrees Celsius. And as you can see that with the increasing the steam flow rate, the amount of gas produced is being increased for both 700 and 800 degrees Celsius. But for 700 degrees Celsius, the optimum amount of flow rate for the highest amount of steam gas used is at 0.65 liter per minute. And but tar is also there, sir, and the tar production is lower, so it is highest at the 0.5 milliliter per minute. So therefore, we find the optimum to be 0.61 milliliter per minute. This is for the result for the gaseous composition, and we can see that we are producing a hydrogen fraction of nearly 50%, which when we did it with the catalyst, it was increased to 70% because of the catalytic activity. But the temperature was also 850 there. Here, the maximum temperature which is shown in the second graph is 800 degrees Celsius. And this is for the hydrogen lead. And as we can see that the highest hydrogen lead is being obtained for 800 degrees Celsius is 0.7 at a steam flow rate of 0.75 milliliter per minute. But for the 700 degrees Celsius, highest hydrogen lead obtained is at 0.65 milliliter per minute. That's all, sir.
One question is this: do I use the nickel as a catalyst?
Yes, sir.
Nickel is a costly.
Yes, sir.
So why don't you try some other material which are cheap? Number one. This is one question. Another question to my mind is that 800 degrees centigrade, you are getting a good amount of tar.
Yes, sir.
And at 700 degrees centigrade, you are getting less tar. It means that as you go on increasing the temperature, tar becomes.
Yes.
And it will yield more gas and more value of hydrogen also.
Yes, sir.
So why don't you try to have these higher temperatures?
Yes, sir. At 800 degrees Celsius, sir, this is still 800 degrees Celsius. For my study was conducted at higher temperature for the same reason only, at 850 degrees Celsius. But above that, the energy required for attaining will be increased. As far as the nickel is concerned, we chose nickel because, sir, it has the ability to absorb or attach the carbon-carbon chain.
That's right. But there are other metals also
Yes,
which have the same ability.
Yes, sir. The other materials are platinum and palladium, and palladium and platinum, but they are costlier than the nickel.
But if you try some lower material, better material which are cheaper, and they have also the ability.
Sir, we tried it with the alkali metals such as sodium chloride, but sir, the results were not. And sir, as far as tar is concerned, sir, this is the product distribution of the overall process for the catalytic part. And we have achieved the minimum amount of tar with the highest amount of hydrogen produced.
Yeah.
So the tar problem is nearly solved in the case of catalytic steam gasification process, sir, with a high amount of hydrogen.
Yes.
I have got some basic question. That whether you do the steam-based gasification by steam or whether you by liquid-based reaction. In both ways, what we are getting a syngas, which is rich in hydrogen, but it has some other carbon monoxide and other thing also.
Yes.
Now, can it be used at our ultimate aim to get hydrogen to be used as a fuel for whether transport or whether whatever industry, ultimate aim is to decarbonization of these sectors.
Yeah.
So, the output of this gasification process, whether by steam or by where it will be used.
Sir,
I don't think it can be used in fuel cell for transport.
yes, sir, true, sir. That is why, sir, from this process itself, the charge which will be produced in this gasification process, sir, that is being used for making a membrane with the polymer such as PMMA or any other polymer, and we are checking that how this hydrogen can be separated with these gases. And and that is
Okay, so ultimately,
there will be some post process.
it will have to go to another process
Yes, sir.
of segregation
Yes,
to get the pure hydrogen.
yes,
But then we have to see the economics of this production plus segregation.
yes,
Both together is a capital cost.
yes.
In another case, the direct hydrogen production is that to this,
Economics is very important.
other where the economic is not other conventional method.
Yes, sir. But sir, this is also you are right, sir, that the all input cost is high, it is a bit cost intensive. That is why research is being going on this and we try to achieve maximum hydrogen production there. And sir, we are trying that whatever we have in situ fashion.
So it means the useful product out of this process is char.
Sir, charge and
Char
gas.
is not a use.
Charge is
That is the objective what the char को use कर रहे हैं.
नहीं, objective is to gather hydrogen.
maximize hydrogen, but we have used that char also to purify the hydrogen.
Alternatively, but basic objective is to get the hydrogen.
Yes, sir. And also, sir, we are utilizing the waste, we are managing the waste.
Managing waste to get the hydrogen.
We are waste to waste.
Is this study also part of the PhD?
Yes, sir.
Is this particular study?
Yes, sir. It was my latest paper, sir.
Part of your PhD?
Yes, sir.
So if you try to get any just from your experimental results, means technically are also which you are doing with. Like that, therefore, also from the medical, so there are possibilities of other. So if you try permutations and combinations, and then probably simulate the process, that may be a part of it. Good.
Yes, yes.
Good, very good.
All of us are thinking about the nickel, use of nickel, which is rare earth metal and as well as nickel. Can we think of having something as a catalyst which can be organic in nature? So it is more environment friendly whenever it is finally disposed of or if we are talking about it.
Organic as in carbon based or?
Maybe anything. I mean, which is environment friendly at the end of the process. Ultimately, anything which is the result part of the process has to go somewhere. That final conclusion is also important.
Sir, we did not land on the nickel by the first attempt. The research paper shows and the details we did the experiments also based on alkali metals, which are environmental friendly, sir. And alkali metals such as sodium, potassium has a high ability for the conversion process and enhancing this process, sir. But directly putting it we did not get that much results. The results were negligible.
Alkaline.
So that is why we tried nickel, and that to dope down the ash, which is ultimately sodium, potassium, and alkali metal.
Right.
So that gave it a better result because nickel alone will be degrading very quickly because of the deposition of carbon. That deposition of carbon is being slowed down or rejected by the alkali metals. So that is why we put alkali metal as a support.
NOH, KOH.
Yes, yes.
How much is the cost of this particular nickel metal to the ratio?
Sir, it is like 500 grams. For 500 grams, we took nickel we to take salt, nickel hydrate, hexahydrate, sir. And in that salt, we calcinate it, and that will also amount to the energy required, sir, also. So we calculated it, sir, to dope the nickel on the ash. But sir, the salt was around 1200 rupees or 1500 rupees per 500 grams, sir.
Okay, right now we are more focused on the technical aspect than once it is established.
It's a pilot plant.
Sir, we want it to be reusable. Whatever the ash we take it for the conventional gasification process, we want it to just regenerate the catalyst. The regeneration is also one of the aspects that can be worked on.
That will be possible.
So I had this my suggestion in my mind like reactivation or regeneration of the catalyst.
Yes.
So is it possible that the affected part of the catalyst use the recirculation process and activated there, regenerated there and again give back into the reactor? Is it possible?
Sir, that depends on how much structure of catalyst would change. But sir, yes sir, this reactor which we used in our university facility was fixed bed reactor only. But there are circularized bed reactors, fluidized bed reactors that can be used, that are being used in the outer countries. They work on fluidized bed reactor only. And one more thing that is there is that we have not introduced the term of pressure here. So a high pressure will not convert it to hydrogen, but definitely it will give the oil part a very good success, because the oil produced after applying the pressure would be much more useful. We will be producing much more of alkanes and more of paraffins, and hydrogenation process can be also. There are a lot of aspects in this research which can be done, which could not be my part of PhD, but definitely there are many future insights from it.
Thank you.
Okay, good.
Instead of the fixed light, use prototype. That is much more beneficial and improve the results.
Yes, sir, if I had a chance, definitely I will do it.
So we move to next speaker, Mr. Vikas Kumar. He will be dwelling upon hydrogen cylinder storage and transportation safety in industrial settings.
Good morning. Sorry, I think good afternoon.
Good afternoon.
It's still good morning. Okay, that's good. Okay, it's nice. And since yesterday we generated a lot of hydrogen, right? So it's time to transport it and use it safely. So that's an important part, as I'm not like a researcher scholars or researchers or professors. I'm mainly work in industries and doing audits, and also whatever the experience I am having, I am more focused on the standards to the implementing regarding the explosiveness. What are the certification, what are the things are indulged in this process. So these, sorry, this is the, okay, no problem. So these are some important abbreviations which we use during this seminar. And apart of that, I shared already the PPTs, which all the probable questions and doubts. So whoever required, please coordinate with the local center and they will share the PPT. You will get a lot of answers, because every question is not answered within a limited period of time. So whatever the possible question, I put into the PPT lecture notes. So the most important part, because rest is the pressure relief valve we described, but the one thing I like to describe this lower flammability and lower explosive limits. That's very important part, because in any environment or any flammable material, fumes comes. So not everything is flammable at the initial stage. There is certain concentration is required. So two important aspects about the flammability of explosive net is LEL and UE. Lower explosive limit and upper explosive limit. When the upper explosive limit crosses, so So that is no enough oxygen present. वहाँ इतना oxygen ही है नहीं होगा कि वहाँ पर आग लग सके, right? And lower explosive limit means इतना fuel supporting नहीं है कि वो chain reaction produce कर सके. Because some students are there, उनके लिए बहुत सारे नए terms होंगे, तो मैं थोड़ा basics भी उनको लिए बता रहा हूँ, so that they got the interest in that. So like अगर मैं एक छोटे-छोटे से blocks लकड़ी के रख दूं और 1-1 मीटर की दूरी पे रख दूं और एक में आग लगाऊं तो बाकी में आग नहीं लगेगी. रीजन लोअर एक्सप्लोसिव लिमिट से नीचे है, आग चेन रिएक्शन प्रोड्यूस नहीं कर पाएगा. और अगर मैं रूम के अंदर पूरा स्टैकिंग कर दूं ऊपर तक और उसमें ऑक्सीजन गैस की स्पेस में छोड़ूं तो भी आग नहीं लग पाएगी बिकॉज़ नॉट सपोर्टिव एक्सिस. बट इन केस ऑफ गैसेस द एनवायरनमेंट चेंजेस वेरी फ्रीक्वेंटली, so we always look for LEL, never look for UEL, because दरवाजा खोलते ही एनवायरनमेंट चेंज होगा, ऑक्सीजन लेवल लेके होते ही LEL से UEL के बीच में आएगा, एनवायरनमेंट explosive बन जाएगा, right? So that is very important. So always all the meters and every instrument is only measure LEL levels. So that's why I explain this. So sorry. So hydrogen is a promising energy source. Since yesterday we discussed that green hai, byproduct water hai, there is no harm to the environment, lot of things free. But nothing comes free. Life में कुछ भी free नहीं मिलता, उसकी कीमत तो चुकानी पड़ेगी. So here is the risk. It's a highly flammable, right? And once it starts flames, you can't see with the naked eyes. आग लग भी रही है तो पता नहीं चल रहा है कि यहाँ आग लग रही है. Invisible, right? So that is a very good concept. And most of the industry uses hydrogen, especially in power sector. And power is the main ingredient to GDP development and everything. And that main ingredient is hydrogen. This is very risky. So the rules of sustainable energy increasing, but it is storage and transportation present safety challenges. And the word safety and sustainability behavioral concept is very weak in India still. Even you go around nearby, people are not using normal PPEs, not wearing shoes while working. So safety for hydrogen, investing amount, large amount, is still industries are very put the back foot on that once they comes about the safety investments. I have experience and they said it's a flame-proof lights installed, but not on insect within this light. So what is the use of flammable lights, flame-proof lights, right? So the high flammability start from 4% to 75%, right? If the 4% oxygen, hydrogen is available in any certain area, that area become a explosive, flammable, and that reaches up to the 75. So that is a big range to make up that area is very highly prone to flames. Then low ignition energy means very low temperature is easily ignite. Even a small putting onto the ground, if the spark comes, even then. Then high probability leading to the potential undetected leaks. Then nearly invisible flames requires specialized detection equipment. This is the major challenge because huge investment required. And as so many young students and research scholars are there, they start working on that because investment on safety industry are not interested. They are interested in production. One of my senior fellows is smiling because they are having the same experience with, like me, right? They are always on a back foot when they talk about. So that's my request to all the youngsters those are present. They start working on that so that they develop some cheaper, right, in the cost to develop the safety measures. Then composite type cylinders, lightweight because hydrogen easily corroded the steel and everything. So that's why we use type 4, which is basically a carbon fiber, lightweight, and it is able to bear up to 700 bars. Otherwise, steel cylinders able to get about 200 to 300 bars. Right? Then other things, it is resistant to impairment, not easily corroded, not easily punctured, modifier. With IoT, you can integrate the IoT and sensors within this. These are all the advantages in this particular cylinder. Then infrared and laser based sensors for real time and continuous monitoring. So what happens in infrared, the particular wavelengths is absorbed by this hydrogen environment, right? So in this way they detect what is if the hydrogen is present and what is the level of the hydrogen present in this. And next is pressure relief valve. There is another modification in that. The pressure relief valve is like when the pressure is high, the automatically that valve is open, right? Another is spring type, where the high pressure opens the spring, releases the extra amount of pressure. Then once the pressure comes within the limit, it is automatically closed. And the combine of both, right? So I already then what are the hazard and mitigation leaks? Permission is that risk undetected leaks forming the explosive system. We already advanced sensor systems like we already discussed in the previous slide, infrared and this. Then high pressure risk, explosive decomposition is PRD and pressure monitoring control. Now we are trying to implement the IoTs in that, so that continuous monitoring. Even we are trying to put the transducer over the hydrogen regulators, cylinders, so that they at the time if the pressure is releasing or dropping, they are automatically detected in the real-time systems. Then that also we have already discussed the high pressure risk, the pressure of explosive PRD, pressure monitoring control. This when the fire exposure risk, the ignition risk due to the low ignition energy, the anti-static flooring like vinyl, rubber, carbon type flooring, so that while dropping the cylinders or moving the cylinders from one place to another, it falls and any spark comes, even then there is no spark produced. And a part of that, no sparking tools. Right, beryllium, copper, and other composition of copper, aluminum alloys. So any wrench, hammer, or screwdrivers, everything made of non-sparking tools. Because spark is very harmful for the environment. But as I have told you that I would like to share the few facts. The place, everything is installed. But the AC is very costly, non-flammable. So they put a normal AC in the office, which is hardly 10 meters from the hydrogen storage area. So these are the things. So whenever you go to any company, please take care of that, all these things. And these are some leading standards, right? ISO 11141 with material capability, then ISO 98091 is the design and construction for steel cylinders, and then NFPA 55 storage handling compressed gases, SE J2579, and NFPA 2 and API RPA 529 is the compressive safety. The material enhanced IoT-based monitoring system for pressure, temperature, and leak detection. This is the real-time challenge. We need to work on that because we are trying to move on the hydrogen systems, but still the safety concept we are not working on that much high intense level in which we are focusing on production of hydrogen. Robust cylinder design and composite materials, proper ventilation and systems to prevent the gas accumulation. In ventilation, there is a natural ventilation. Just 1 minute, sir. For your due respect. Natural ventilation, forced ventilation, a part of that. During the flammable environment, ventilation required. Explosive environment, ventilation is required. And the scope for the youngsters, those are sitting here, is the developing hydrogen resistant materials, because hydrogen is very corrosive, right? And carbon fiber is very costly. Then cost effective and reliable sensors in as much as cheaper cost you can able to provide, right? And the comprehensive risk management models. Conclusion, to fully harness hydrogen's potential as sustainable energy sources, adhere the international standards, advanced equipment, continuous research are crucial for safe storage and transportation, because very now we are treating the hydrogen cylinders like a normal cylinders, usually in the industrial practice.
So the transportation is by liquefaction.
Sir, the problem is the liquefaction and the ammonia yesterday we discussed, right? But at the other hand, when we doing all these things, the cost is increasing. Because once we talk about the industry, everything is techno-commercial. Once this will start increasing, company first hit always on safety and sustainability. Sara, because company is focused on two things, production and sales. Right, sir? So that's our experience, what the things are going on. And due to all these 18 years of experience in health, safety and environment, we start this third foundation, right? I am leading this, and we are focusing to cultivate safety and sustainable seeds into the youngsters, so that whenever they will become a manager, engineer, CEOs, entrepreneurs, business owners, whatever, the first plant they cultivate in their own organization is safety and sustainability. So that we are discussing next time not the safety, but we focus more on latest technologies. Because safety and sustainability moves from top to bottom. And people on us are not realizing this fact. I think most of the people, those who are in this industry, I agree with me.
What about its compressibility?
Sir, in compressibility, again, because when you compress into the cylinders, right?
Yes.
Yes. So the high amount, because it's very risky, you need to become a 10 times capacity required of the cylinder. Whatever the pressure you are doing, minimum 10 times for safety. That's why the carbon fiber was 700 bars.
होता है compression होता है, नहीं होता है या
Yes. Thank you so much.
very nice, very nice.
Yeah, there's only nothing directly to your presentation, just a small clarification.
Yes.
Sometime back, a video circulated on the social media. Is somebody carried a small hydrogen cylinder in the lift?
I think, sir,
Could it be due to leakage?
quite possible. Mainly because what happens, sir, I can explain you the real-time scenarios. हाइड्रोजन सिलेंडर्स लोगों को ये रियलाइजेशन ही नहीं है कि वो कितना रिस्की है। उसका जो ऊपर आपके वॉल्व और सील लगे होते हैं, उसको भी वो ऐसे डील करते हैं जैसे हमने डर के सिलेंडर को ऑन ऑफ कर दिया। वो गिर रहा है, अगर आपका हाइड्रोजन सिलेंडर एक बार भी गिर जाता तो लीक शुरू हो जाएगा।
Whatever is the secondary reason, primary reason could be leakage.
Definitely, leakage is definite. First reason, अगर एक्सपोजर होगा तभी हो सकता है जब उसमें से बाहर आएगा। ब्रिटल, यस, वो स्टील को ब्रिटल बना रहे हैं, स्टील को हम कार्बन फाइबर होके जा रहे हैं और अंदर ग्लास लैमिनेट प्लास्टिक नहीं लगा रहे हैं।
And then it is basically due to electrostatic depression.
Any question?
I have one. You mentioned that you are using IoT and sensors.
So, companies are using, we are working with them.
Okay.
We are working with them. We are working with Honeywell. We have tried to work with the IDB. Whatever the challenges we are facing, that's why I started this foundation, because our youngsters are having a lot of energy and enthusiasm and curiosity. But because of not proper guidance and to direct that energy, we start this foundation so that we can come up with real-time challenges thrown to the students so that they can work on that.
So your foundation is still working on the safety aspect, right?
Yes, safety and sustainability.
They are not, the systems are not yet developed.
Not.
In
I'm
progress.
very honest, because after 17 years I tried to connect so many institutes and all these things during this tenure. Why not we implement all these things? But normally in India there is nobody interested in this aspect.
So you can't mention the cost involved in the storage safety.
Yes, sir?
Is there any cost you can mention?
No, sir.
No.
Because if I mention a cost, तो already cost is big challenge. अगर मैंने पहले दिन कह दो ना एक सर इतना cost लगेगा, तो आधे लोग तो वही कह देते हैं सर कुछ नहीं होता सर कहाँ होता है जिस दिन किस्मत में लिखा रहा उस दिन हो गई है कोई फायदा नहीं
To
होता.
this audience, if you can mention the cost, then they will be more, knowledgeable.
Sir, cost of what you are talking about?
So safety aspect.
Sir, cost of safety aspect depend upon how much big plant you have, what is the storage capacity you are designing. It's all depends on a lot of parameters. If you don't have a space proper, then not natural ventilation is possible, then post ventilation, adding the cost. Is this office near to this, adding the cost. Is this office not near the only one security guard, open area, cost is different.
Cost versus accident cost.
Yes, exactly. It's an iceberg theory. 30% ऊपर है, 70% नीचे से कोई नहीं देखना चाहता.
And any more questions? No. Okay, thank you, Mr.
Thank you so much.
Can I request Mr. Vidya Goyal, please, to speak on green hydrogen generation, storage and safety aspect?
हेलो सभी को मेरा नंदन एवं अभिनंदन. Respected Pugul Gupta sir, C Gupta sir, all the chairperson of the session and all my dear friends and colleagues. Just I would like to give some brief about me. After doing my graduation in electronics and communication in 1988, 36 years back, I joined this highly reputed international acclaimed organization IPEC Limited. And we have the proud feeling that this organization has grown from 0 megawatt to more than 76 megawatt, and if we include the project in pipeline, so then we are crossing the 1 lakh megawatt capacity. And top of that one, apart from adding value to the nation, just few days back, we were having a program where Honorable Power Minister was there, Manolal Khattar, and that program, our CP was sharing with the audience and the persons that NTPC, the equity which the government of India has put in NTPC is 7,500 crore, and what NTPC has returned over a period of time to the government of India, it is in the range of 4 lakh crore. So one can understand how much money got multiplied through NTPC to the government of India. So, and regarding my experience, I have worked in different projects across all, I will say 8 states of the country and around 10 projects. I have experience in the coal projects, larger projects having 3,000 megawatt and more. We can understand the 3,000 megawatt project is of the quantum which can feed half of the Delhi. So 2 projects of 3,000 megawatt can feed the full Delhi requirement. And some of the portion I have worked in the engineering also, 8 years in engineering where the design and all those aspects we take care. 5 years I spent in the commercial aspect where we file the tariff petition and calculation how the project viability is calculated. What are the basic principles on which the project viability is calculated? As head of the new projects, I handle many projects for NTPC for evaluating the availability criteria, deciding the projects. My recent assignment, which I have joined 2 months back, environment, different technology. It is spread from the coal to the gas to the hydro to the wind to the now to the hydrogen. So in that background, I will start my presentation. One thing I would like to add that presently NTPC is having 25% capacity, 19% capacity of the country. On that capacity, our efficiency is that we are supplying 25% power to the country. So that is the single statement that speaks the efficiency of the NTPC. This is the first slide that shows the history of the hydrogen. I put that slide to gauge at how old the hydrogen is, what are the different uses at different point of time. Because looking towards history is as important as making planning for the future. Because looking at the history, we get the information regarding what needs to be done and how much has to be done previously. So the hydrogen economy, which is a buzzword these days, it is as old as 1970, so we can say it is more than 50-year old now. If you talk about the hydrogen, it is one of the most available element in the universe. Sun and all stars are mainly made of hydrogen. That is the important aspect. Whatever energy we get from the sun, most of the part comes through the burning of hydrogen. As per sir, 90% of the stars present in the universe are made of hydrogen. So hydrogen is at the same time whatever fuel we will use or whatever fuel we are using presently all contain the carbon and hydrogen. These are the two important elements, whether it is the methane, whether it is petrol, diesel, coal, anything. So hydrogen and carbon combination, we can say ये चोरी का मन का साथ है, मतलब जहाँ भी आप फ्यूल में देखेंगे तो कार्बन हाइड्रोजन साथ साथ मिलेगा. Now we come to the physical properties. One of the positive aspect, non-positive. Tearless. Being tearless, we will not be knowing the leakage. That is the negative aspect. Gas at ordinary temperature. Very low boiling point, minus. So compressibility requires a lot of energy. And density, one can think of. Density is very, very low. This is the lightest element in the periodic table at number 1. Now we come to the chemical properties. As my friend has already explained in detail, 4 to 75% or 74, whatever say. High enthalpy, that is the positive aspect. When in a mixture of chlorine, hydrogen can explode even in the presence of sunlight. In NTPC, in all the generators, which are about 200 megawatt, right now the generators are of size of 800 megawatt. Hydrogen is the basic element for the cooling purpose. Earlier we were producing hydrogen in our own plant, seeing the repetition and all other things. Now we are preparing from outside and storing that one. So hydrogen production is one of the, I will say, long back process which we have handled. But what my friend has shared, that it is highly risky. Any single mistake can be the only mistake of the life. That is a critical element that we need to take care. Whatever instrument, whatever equipment we use, it should be spark free, and that carries a lot of cost. That is the one of the aspects. Similarly, when we talk about the hydrogen, so then the first use of the hydrogen comes to the in the terms of ammonia, what we know, and ammonia is then converted to the urea. This is the one of the basic use of the hydrogen where we talk about the hydrogen. Earlier, the people who are having of my age, they will be knowing that the earlier डालडा was used basically. अभी तो यंग जनरेशन को तो शायद मालूम नहीं होगा. तो उस टाइम डालडा आता था और सब वो ब्रांड नेम भी मतलब चलता था. अभी की तरह नहीं रहता था कि आपके 10 ब्रांड हैं. उस टाइम में बहुत ज़्यादा हाइड्रोजन यूज होते हैं. तो उस टाइम इसलिए मेरे ख्याल से seeing a lot of use of hydrogen and its replication, the government has changed the process now. Most of you are coming in the liquid form. It can be used in internal combustion engines in the form of fuel, which we are talking, because due to the environment. Almost, if we calculate, we will be coming to the slide, in India, almost 60% of our petroleum product goes through the transportation. If we are able to resolve the issue of the transportation through any other mean which is having less carbon or which is carbon free, so a lot of problem of pollution and the carbon problem can be solved. So that is the area where Government of India has focused, and they are primarily aiming to make this one. This will solve the two problems. One will be the import will get reduced drastically because 80-85% petroleum products are imported by us, and at the same time we will be able to tackle the problem of the pollution. Yeah, one of the things was that the hydrogen is basically colorless gas. Yeah, that is the basic property of the color. And now we talk about the green hydrogen. So how it comes from that one. Now we will be talking on that one. These are the different colors of the hydrogen. The original gas is the colorless, but the type of production, how we generate the hydrogen, give it the color. Grey hydrogen, when it is produced from the fossil fuel. Blue hydrogen, when it is processed through the natural gas, because the gases are having less impact, so color changes from grey to blue. Black and brown, we can understand when it is produced purely from the coal, then it is totally black, and when from the lignite it is brown. White hydrogen, this is the hydrogen when it is produced through the nuclear energy, because production of hydrogen will require the energy. This is the energy intensive process. So we will require a lot of energy. Pink hydrogen and turquoise hydrogen, yellow hydrogen when we are using the solar power. Now we talk about the green hydrogen because the hydrogen is to be produced through the renewables, that can include other than solar. Yeah. Yeah. Yeah, these are the other colors of the hydrogen: red hydrogen, purple hydrogen, golden hydrogen, and green hydrogen, which we are talking, and which is the theme of the seminar. As from the class 8, we know that the H2 plus O2 is the H2O, and now we are talking about the reverse process of that one, electrolysis of the hydrogen, where we are focusing these days. This is the use of the hydrogen, which is at present. So we can see 55% of the hydrogen is used in the production of ammonia. Remaining 25% petroleum, I will require for 5 minutes more actually because of some glitches in the computer.
So can you finish in 2 minutes, please?
2 minutes it will be difficult actually, then I will not be doing the justice to the presentation because still the safety part is remaining on which we are talking.
You can get the generation part.
Okay, I can skip the generation part, no issue. These are the things as I think it has been already talked. I will be skipping this one. This is the, we will talk half a minute about the Government of India hydrogen mission because that is the important aspect of it. Okay.
Come to the direct, he is very right.
These are the different intervention of the government. These are the enablers. Enablers of Government of India. Mission outlay, they have given the 20,000 crore. And beautifully they have divided these 20,000 crore in different aspects so that each one is getting some allocation around 400, 500. That is the beauty of the national mission plan. Storage already here start, just I have given some numbers actually. Now we talk about safety. I will say the safety is like our health. We do not feel the presence of our good health, but definitely we feel the absence of good health. अगर जब तक हमको डॉक्टर ये नहीं कहता कि भाई आपका बीपी बढ़ रहा है जरा घूमिएगा, तब तक हम उस पर ध्यान नहीं देते। एक बार डॉक्टर ने कहा कि भाई आपका शुगर बढ़ रहा है, अगले दिन से उसने चाय भी पी की और मिठाई को दूर रखिएगा 2 मीटर। तो सेफ्टी का लिए है कि जब तक हम सेफ हैं तब तक हम सेफ्टी की वैल्यू नहीं समझते। जिस दिन कोई इंसिडेंस होता है उस दिन हमको समझ में आता है। और दूसरा जो सबसे बड़ा मेंटल ब्लॉक है, जो कि मैं बात करता हूँ अपने वर्कर से भी बाकी लोगों से, हमको ये लगता है कि अगर वो पड़ोसी का एक्सीडेंट हुआ तो हमारा तो नहीं हो सकता उसी कंडीशन में। वो मेंटल ब्लॉक जब तक हमारा दूर नहीं होगा कि जो पड़ोसी के साथ हुआ है, जो किसी फ्रेंड के साथ हुआ है, उन्हीं कंडीशन में अगर मैं रहूंगा बिना हेलमेट के, अगर मैं स्कूटर चलाऊंगा और रेड लाइट पे जंप करूंगा तो कल मेरे साथ होगा, कल नहीं होगा तो 10 दिन बाद होगा। तो ये मेंटल ब्लॉक जब तक हम दूर नहीं करेंगे तब तक सेफ्टी हमारी हैबिट में नहीं आएगी। सेफ्टी को कल्चर में आना है, सेफ्टी को हैबिट में आना है। जो हम सेफ कंडीशन घर पे करते हैं वही सेफ कंडीशन हमको अपने वर्क प्लेस पे करनी है। तो these are the definition of safety which we have thought of actually. This is not the standard one. I will say sustain accident-free environment throughout the year. That is the emphasis. Our emphasis is all the activities are set 24/7. We say 24/365. Actually, this slide, this is having one more. This totally is not coming on this page. These are the different safety aspects of the hydrogen use. One aspect is flammability, which we have already talked. Leak detection, because lighter weight, difficult to detect. Material compatibility, non-toxicity, immovable flame, another important one which my friend has talked, because we are not seeing the flame. With the burning, we will be only feeling. And ventilation. Is it said that the most effective method to control this is to eliminate this one? If you can eliminate, but most of the time it is not possible to eliminate 100%. This is a chart which speaks how the safety should be handled. If you can eliminate, nothing better than that. Otherwise, PP is the last resort. It is the last protection given to individual. Now this is the chart which speaks about how the hydrogen damage the material. Embrittlement can be from the different rate, different combination. So these all things need to be discussed in a separate presentation. Just I am putting in a one slide to give how much brittlity hydrogen produced in different ways. These are the different aspects. What we need to do, what care we need to take. Inner chambers and purging lines. Whenever some leakage is there, we should have a limit of purging. Limit already we have discussed. Ignition source management. mechanical integrity and reactive chemistry, leak and flame detection, ventilation and flaring, inventory management and facility spacing, which he was talking, we need to have the more space when we are talking the hydrogen. We have said about the NFPA, which part is applicable, which standard will be applicable. Exclusion, how it can explode. Residual life calculation of the plants, how we can calculate how much life is left over in different conditions. These are the human aspect where we need to take care. Training is one aspect, preparation of checklist, entity, technique for the human error rate prediction, human error assessment and reduction techniques. These are the different techniques. This is the safety overview of the assessment. Now we talk about the anti-physical condition in the national mission. So in Pudimatta, yesterday this has been taken care of, and NTPC is putting this one plant where the apart from hydrogen, ammonia and green methanol and green urea, all three combinations will be there. This is the latest the bus on the hydrogen. This bus we are using in the Leh, where the fuel transportation is difficult. 5 buses are there. We are having a hydrogen filling station which is run by solar panel. So this is the practical example which we are using at Leh at such a height. So that proves the process of the using the hydrogen in the transportation, which is the important element of the whole process of the mission, national mission of green hydrogen. That's all. Thank you. Thanks a lot.
Any question to Mr.
We are also making green hydrogen by the process of electrolysis.
Yeah. Actually, what we are thinking at Pudimatta, we will be developing the basic infrastructure, and then it will be allocated to different companies, because for a single company to produce at that scale may not be feasible or may not be possible due to the investment requirement of that fund. Right now, it will be on the same model what the country is doing for the 30 gigawatt this solar park at Rajasthan. So this in Gujarat, sorry. So this is on the same scale. Almost 10% of the hydrogen will be produced there, and it is near to seaport, and the export of this hydrogen will be easy, because now the India is planning to export that one, because it will have the high value, and once we are through that one. But one of the main roadblock in the production of hydrogen, as I think, it is the development and the manufacturing of the electrolysis, which I have talked in my presentation.
Because there was an issue about the material of the
Yeah, right.
that is very positive.
Right. Yeah. On that one, Government of India has focused actually around 60 to 70% cost of the process, electrolysis process which we talk, is of the electrodes. So now the assignment has been given to the other thing. Reliance is going in a big way for that one, for meeting that requirement, because that will be required at a large scale. So a big industrial house can take care of that one. So around, this is linked with the PLI, as I think. This one with the manufacturing of that one. So in that one, the budget allocation is also part of that one.
You mentioned you are setting up the green hydrogen hub at Andhra Pradesh.
Yeah, I am talking about that project.
And then, in that connection only, what is going to be the capacity of hydrogen production there?
Their hydrogen production capacity, which we are envisaging, is around 5 lakh ton per annum. Almost
We will mainly use only for production of ammonia and
This is the thing where we have talked about the Pudimatta Andhra Pradesh project.
5 lakh ton per year.
Yeah, 5 lakh ton per year.
And it will be used mainly for green ammonia and green.
No. Apart from this hydrogen, this will be the other production.
That is was basically for the ammonia, and from ammonia, urea can
No, this will have the 4 elements. One element is the hydrogen, which we are talking 5 lakh ton. Another element is the ammonia, 4,500 ton per day. Another one is green methanol, and third one is the urea. So these are the four distinct products which we are talking. That's why this project is the very, very ambitious project of the country.
So that way it is ultimately going to produce $1 per kg.
Right now it is difficult to say, but the efforts are on for that price. And you will see the investment is 1.85 lakh crore, but whatever the revenue of the NTPC right now, it is equivalent to that one, that investment is required.
Now you mentioned yellow hydrogen by solar and green also by solar. What is the difference?
Actually, the difference between two is green hydrogen is the hydrogen produced through renewable. It can be solar, it can be wind, it can be another form, it can be hydro also. But when the hydrogen is produced through solar, then it is the yellow.
So actually PC is focusing on the process of conversion of the green hydrogen.
And this is not focusing on the production of the electrode, and this is not going electrode.
There are other routes also for the
Right. Because when the country has to do something on a scale of 5 million ton, where the total production across the world may not be right now, even in the terms of 1 million ton. So one can understand a single player cannot fill all the gaps. There has to be 4-5 major players. As I have discussed this 30 gigawatt solar park, there are 5 major players who are executing the solar of the 5,000, more than 5,000 megawatt. 5,000 megawatt is solar is a very, very big project. Spreading across kilometers and kilometers. So a single player, it will be difficult to execute this magnitude project.
Biomass gasification remains one of the most promising route for making the green hydrogen.
You are right. Actually, all these things are good when we are at some small scale. When we want to go at big level, then we have to go in a large scale where the investment will be large, technology should be proven, there should be big players. So at the lower, at micro level, we cannot achieve the target of even 1 million ton. 1 million ton is a very, very high quantity of hydrogen.
Just a small curiosity.
Yes, sure.
1,600 acres. So definitely you are going to put up the solar plant over there for production of hydrogen.
Part of that one will be solar, and part of the power will be arranged through our other solar plants. May not be directly solar at that place, because we are going for the 60 gigawatt of the solar in the year, maybe next 8 years. So out of 60 gigawatt, maybe we may have the 5 gigawatt there, and maybe another we can supply from other source.
Ultimately it is solar power.
It is solar power.
Obviously, because you are the power sector company, you will get it from your own.
Right. Being the power company, तो अभी हमारा obligation भी है कि जितना हम coal produce करते हैं power, उसको हमको सब combination में solar ही देना है.
So it will be support for direct consumption of power and also use production for hydrogen.
Right.
Andhra Pradesh में now wind can also be wind power also.
All options are open actually in such project. These are the multi-purpose projects जो हम लोग पहले हाइड्रोजन में कंसेप्ट यूज करते थे. Multi-purpose projects.
Both of them.
Sir, can we go to the next presentation, please?
Basically requirement क्या लगती है गवर्नमेंट की वो सब फॉलो करना चाहती है.
देखिए, we should be realistic. Actually क्या है कि कोल तो बंद नहीं हो सकता. What I see, at least in my life, maybe another 20 years, we have to be at that one. However, we can reduce the intensity, and our demand is growing up. At least if we are contained to some 30, 40, 50% even, that is also appreciable.
Right. You can India it will not be possible. Because in UK they have closed the program.
थोड़ा बंद करके संपवाना है और थोड़ा
Actually थोड़ा सा मैं ये शेयर करूँगा कि जो आइडियलिस्टिक कंडीशन रहती है ना दुनिया में, वो बड़ा फैंसी लगती है. और प्रैक्टिकली जब यूके में भी जब पावर क्राइसिस हुआ, देन अगेन दी थॉट ऑफ कि हमका जो प्लांट बंद होंगे उनको रिवाइव किया जाए, तो वो भी उसको रिवाइव करने की सोच रहे हैं, क्योंकि ऑल द टाइम यू कैन नॉट डिपेंडेंट अपॉन द renewable. You need to have some backup. Backup is only two part. One is the battery, one is the large hydro project, which we call PSP. So PSP takes around 8 to 10 years.
Basically
practically possible.
सर थोड़ा सा मैं इंटरप्ट करूंगा। मैं कहूँगा कि जब शुरू में शायद हम में से किसी ने भी नहीं सोचा होगा कि कुछ ऐसा भी हो सकता है कि वायरलेस कम्युनिकेशन हो सकता है। तो इनिशियली जब भी चीज आएगी तो एक क्या कहते हैं वाइड आइडिया के साथ शुरू होती है।
Can I request?
Okay, thank you. I have taken too much time. Okay, thank you.
Sir, you can have a question with the lunch time. Sorry for that. Next topic is process simulation of crude oil distillation using ASPEN HYS.
Is there anybody? What is your name?
Bushra Khatun, Vikas Kumar Chaudhary.
You are Vikas. The reason is that this topic is not directly linked to anything. So you have to be very clear.
Hello, good afternoon, respected professors and other dignitaries. My name is Vikas Chaudhary. I am a research scholar from NIT Allahabad, doing PhD under Professor GHAZIABAD. And currently I am working as an assistant professor in Chandigarh University also from past 1 year. Chandigarh University. Okay, so my topic is, actually this is not my topic, my one PhD colleague is doing a project in this one, presenting her work. So basically this is a study of crude oil distillation using ASPEN HYSYS. ASPEN is a simulation software we are using for the crude oil distillation. In the crude oil, we know there are a lot of parameters which we need to study to optimize and to enhance the production of crude oil. Okay, because in this industry, you know, there are we need to reduce the emissions also, because nowadays we are moving towards the renewable sources, green energy sources, and the government is planning to reduce the dependency on the crude oil. But still, we need some technological advancement to enhance the production and some new technology to reduce the emissions like CO2 emissions, NO2, NOx, SOx, etc. So these all things, you know, the crude oil. There are a lot of processes to refine the crude oil. There are two types of distillation in crude oil, ADU and VDU. So in ADU, we are getting the multiples fractions of crude oil, and at the top, yes. No. So, okay, this is the importance why we are studying the crude oil distillation using ASPEN HYSYS, because in ASPEN we simulate our distillation column in brief and study all those parameters which is nearly not possible with the column. Okay, so we just put our column and all the parameters put in, okay, and just get the results and how pressure, temperature and other things affect the process, and we can go to the industry and tell them that you have to apply these things to enhance your production and to reduce the emissions. So these are the various factors that why this is necessary for environmental and safety considerations, for economic considerations, for research and development. Okay, and this is the ASPEN HYSYS software, which is a very yes sir. Okay, ASPEN HYSYS software is basically a very useful software, and in this software you just need to put the parameters and it will automatically study all those things, okay, with the help of the algorithm saved in it. Very user friendly interface, you know, it doesn't need to do coding or doesn't need to apply the algorithm in it. It already saved in that. You just need to apply the changes. And these are the results. This is the flow sheet. Okay. पूरी है। पूरा नहीं है।
हो जाएगा सेटिंग थोड़ा सा बेटर
Reduce the
इस पर करेक्शन करना होगा तो लैपटॉप में
This is the flow sheet. This is a rough flow sheet. One basic flow sheet of ADU distillation in the refineries. Okay, where we study the various parameters like process temperature, process the pressure, concentration, and these are the various results we are getting from the expense software. So basically, this is a calculation based on the simulation, and we need to apply this on the experimental work also to validate that result. So next part we will doing that these results should be validated with the experimental part also. So this is the one part of the study. Second part, this is under doing project, and in the next semester we are doing the experimental work also to validate this. So thank you for.
Last call.
Sir, लगे हुए हैं से
Is there anybody that to represent that is go?
I just want to summarize the technical session number 3. Yeah, section number 3. So, what I gather is that India is positioning itself as a leader in the global clean energy transition by developing green hydrogen production facilities and infrastructure. India stands at the forefront of the global green hydrogen economy. Numerous outstanding Indian companies are actively engaged in developing innovative projects. Just like Mr. Goyal said that, I also noted down, I was discussing with him that NTPC is developing the project at NISE. India has significant RE generation also and green hydrogen production capacity to transition the country to net zero and improve energy security. The National Green Hydrogen Mission, a program launched by Government of India, somebody said the 19,000 crores, somebody gave the figure also. To make India a global hub for the generation, use and export of green hydrogen and building upon country's achievement of becoming the first to meet green hydrogen commitment made at 2021 Paris UN Climate Change Conference, which is 9 years ahead of 2030 target. This seminar, today's seminar, provides an ideal platform for the thoughtful speakers from various industries and experts of this field to convene, discuss, and strategize a way to propel the green hydrogen mission to take country forward. I am confident that it will facilitate the sharing of best of technologies, which I have already seen since last 2 days. An exchange of ideas involved is not only in generation, but storage and safety aspect as well, to contribute to achieve the mission of 2030. Just for today's session, we had first speaker H2 Fast Bio CNG Energy, which is very interesting. And he said that within 25 years gestation period, and bio-CNG process is very useful. Second speaker was Ayush Shahzada. I think it has generated a lot of interest in this topic. He has used the food waste, which is a really a challenge for today's world, and India is progressing fast. I am pretty sure that Mr. V.N. Grover, I know him, he is actively participating in this challenge. He says that gasification can produce 75% of hydrogen, but this process is still in the research mode. And then third was Vikas Kumar. He has told about hydrogen cylinder storage and transportation safety in industrial setting. He tries to use of IoT sensors and still cost-effective measures. The actual cost which is happening, which will curtail with the safety practices, yet to be come out. And then Mr. Vijay Goyal gave a very large picture of NTPC, what NTPC is doing. NTPC is the largest energy producer in India, and now they are launching in the green hydrogen also. Andhra Pradesh project is trying to project 5 lakh ton. Am I right? 5 lakh ton or 5 million? 5 lakh ton annually. And he has also emphasized on human aspect in the safety. And a lot of speakers today, they have told that hydrogen gas has a challenge in the storage because it is lighter than air, by which it accumulates into the ceiling, hence needs proper ventilation. Hydrogen burns with a very nearly invisible flame. So special gas or flame detectors, Mr. Vikas also told that very special gas and flame detectors are required to prevent explosive atmosphere from forming. And hydrogen is the flammable gas, which can form explosive mixture with the air. We have to use approved containers only. Am I right, Mr. Vikas? So we have to use only approved containers or tanks that are going strong enough to withstand embrittlement. And PPE, which is a base of the pyramid, and I have also 37 years of experience. I know how the PPE is being used in the industry. Forget about the hydrogen industry, but every industry, PPE is being used now. Yes. But these are not being used. So PPE and training of safe practice, regularly maintained equipment is mandatory. Regarding transport, hydrogen transport involves the use of technology to transport hydrogen from the point of generation to the point of use. Yesterday also we were talking of converting hydrogen to ammonia and then ammonia to hydrogen. But today it was discussed that it involves a lot of money. Then in safety, it is highly flammable, requiring very little energy to ignite. Mr. Vijay? Oh, I'm sorry, Mr. Vikas, sorry. So however, it is very low density, which allow leak gas to rapidly dissipate rather than accumulate as a high density gas. And we should use the spark-free equipment, and these are the things which I think which will tell us how we should store, how we should use the safety practices, and how we should use the safe practices. Right? Thank you very much for a very enlightened speakers. I really thank to all the speakers, to our institution of engineers to organize this today's seminar. Thank you very much.
Thank you, sir. Well conducted this session 3. Moving ahead now, it's a time for the moment to I would request Engineer Puneet sir to please give memento to Mr. S.P. Sharma. I request session chair to be in the photo frame, please. I would like to request Engineer Mukul Gupta sir to please give memento to Ayush Raizada.
Ayush. Sanjeev Yadav के student. Sanjeev Yadav, student.
Now I request Engineer Puneet sir to please felicitate Vikas Kumar.
Vikas.
Now I request Engineer Puneet sir to please give memento to Mr. Vijay Goel.
I would like to thank you for blessing on that.
May I request all these this session presenters to be in one photograph, please? One photograph for Vikas Kumar Chaudhary. Okay. I would request Dr. S.C. Gupta sir to give memento to Mr. Vikas Kumar Chaudhary.
It hardly matters.
May I now request for one group photograph for this particular session, please?
Everyone, this moment also. Thank you.
Thank you so much, everyone.
Thank you all. Thank you. Thank you. Thank you.
In continuation to this, we will be starting. Okay. We will take a 5 minutes of gap and then we will start technical session 4. There is one more announcement. If anyone is having PPT for this session 4, please hand over it so that we can maintain that time gap. All the presenters of session 4, technical session 4, are requested to please provide their PPTs.
और गुप्ता जी कुछ कमी अभी हो तो बताओ।
हाँ हाँ बताएंगे।
हाँ जब ये आगे कुछ सुधार हो तब भी होता है। हमारी इसके बाद खाना खाते ये कर लेंगे अगर सेशन चेयर ये ठीक है हाँ वो बड़ा बड़ा
Ladies and gentlemen, so we are starting with our technical session 4. Topic of the technical session 4 is upskilling in other dimensions, and our session chair is Professor Dr. Meenakshi Sharma. Dr. Meenakshi is currently the Dean Student Welfare at IPEC and coordinator of Internal Quality Assurance Cell IQAC. Ma'am, I request you to please chair this session. First, I would like to invite Dr. S.C. Gupta sir to please welcome ma'am by sapling.
Please be on your seats.
We have received 7 research papers for this particular technical session. Mr. Narendra Royal is absent, rest 6 will be presenting. Yeah,
शूट करा मैडम शूट करिए being based.
A very good afternoon to each one of you present over here. So we are starting the fourth session. For the 2 days, it was an extensive deliberation among all the researchers and the experts in this field. Although the topic is so trending and the work that is going on, and we came to know through this platform how people are thinking in this direction of generation of green hydrogen, transportation and its safety issues also. For the 2 days we could see there were a lot of deliberations and we could come out to the conclusions that this should not be merely related to the conference or any seminar and stop there itself. It should be, what I realized was, it needs a consistent work, and such kind of seminars definitely give a thought, invoke the thoughts in mind that this is the crucial topic and we should definitely look into what all research work we have done. We should come to a common platform so that the things are executed and further taken care of. So without taking much time, I would request the first presenter, Mr. Praveen Kumar Dugal, who will be taking up the topic safety for green hydrogen generation plant. Please, sir. Moreover, since we are short of time, we would request that kindly strictly adhere to the timings and then proceed. Thank you.
Good afternoon. So myself, Praveen Kumar Dugal, PK Dugal. I served in NTPC for 30 years, heading all the safety departments, worked in 5 projects from zero to commissioning, starting with Badarpur, then moved to Korba, then Balco Captive, then NTPC Dadri, then last was Faridabad Gas. So I am purely concentrating on safety issues because my previous speakers have done a lot of things on hydrogen safety. So I don't feel I am an expert on hydrogen safety, but I can see what best can be done to achieve safety. Because we always talk of safety. Safety first, safety first, we give value to safety. When we ask, do you give value to safety? Do you consider the person who is working in safety as a person working in production? So production people get benefit of it. So lip service shouldn't be there. Lot of expenditure has been incurred, shown here. I was just talking, if we put a bus, hydrogen in bus and starts in Delhi, what will happen if it explodes? क्या होगा उसका? तो ये चीजें हैं, but we are optimistic हूँ, सब कुछ होगा, धीरे धीरे होगा. अभी आप देखिए पहले we started with, पहले कहते थे पेट्रोल महंगा है, तो वो लगाते हैं एलपीजी सिलेंडर लगाना शुरू किया. अरे एलपीजी में एक्सीडेंट हो रहे हैं, then we move to CNG. अब CNG में लाइनें लगी हुई हैं, तो now we have to do EV. अब EV के लिए लगा तो दिए, आपका चार्जिंग स्टेशन नहीं है. हमारी सोसाइटी में चार्जिंग स्टेशन बनाया तो लोगों ने ऑब्जेक्ट किया, who will pay for this electricity? So I don't say that safety नहीं होनी, safety is a priority. Safety should be given importance. अगर आप देखेंगे cost of accident and cost of safety, cost of safety is 1/4 and cost of accident is 3/4. एक आदमी मरता है तो 10 लाख का खर्चा होता है, अगर उसको 20,000 के PPE दे दिए जाए तो they can save lot of money. So start. मोस्टली मेरा जो आइटम है कवर कर चुके हैं मेरे सीनियर्स ने, उन्होंने मेरे से भी एडवांस आगे कर दिया है, बट स्टिल आए हैं तो दूसरे तो दिखाएंगे करके थोड़ा बहुत. But my language will be very simple. I discuss it because I have been given lot of training in the NPTI, and I have seen the persons who are engineers. They are coming with big expectations. But when we talk, if you enter a plant area, what sort of hazards you will face, nobody knows. उनको पता ही नहीं है कि अंदर जाके करना क्या है, बेसिक चीजों से एंड दे आर पीजीडीसी किया हुआ उनको। तो वहाँ हम ये कहना चाहते हैं कि सेफ्टी को जब आप प्रायोरिटी देते हैं तो सेफ्टी है क्या? व्हाट इज सेफ्टी? एवरीबॉडी को सेफ्टी होना चाहिए, सेफ्टी फर्स्ट के झंडे लगाएंगे, नेशनल सेफ्टी डे मनाएंगे, नेशनल फायर डे मनाएंगे, नेशनल एनवायरनमेंट डे मनाएंगे, नेशनल फिर अगर मदर डे मनाएंगे, फादर डे मनाएंगे, क्या है ये डे? Isn't it for all these 365 days? क्यों सर? सब कुछ होना चाहिए ना? तो ये ग्रीन हाइड्रोजन का क्या है? मैं तो सिंपल वर्ड में बोलता हूँ जीरो एमिशन। अगर जीरो एमिशन है तो हमारी ग्रीन हाइड्रोजन है, अदरवाइज मिक्स है। अब आपने सामने बताया जैसे हाइड्रोजन कूलिंग वी आर यूजिंग फॉर जनरेटर कूलर, जनरेटर के लिए यूज करते हैं कूलिंग पर्पसेस के लिए। एंड आई हैव सीन इन फिजिकल इन माय प्लांट्स आई वाज मोर कंसंट्रेटिंग ऑन दोस इश्यूज। भाई इसको आपने बैटरी लगाई है, इसको कवर करिए, ऊपर इसका मार्केट गोइंग परफेक्ट होना चाहिए। सो मेनी टाइम्स आई गॉट इन पर्सन विदाउट प्रॉफिट्स, दे वर डूइंग वेरी जॉब। So धीरे-धीरे awareness आई है। I don't say कि awareness नहीं, awareness आई है, but people has to be, and it starts on the top. The person who is a general manager, he is going in the plant area without helmet, and he is asking the person where is the helmet. So ये चीजें जो है, being a black person, मैंने I spent about 40 years in safety. अभी I have been to DMRC, I have been to NCRTS, I have been to Tata Steel, I have been to zinc plants. सब जगह सेफ्टी के लिए मैंने कहा ये करते क्या हो? Let me talk something about audit करेंगे. Before you finalize this report, ना, please consult us. Mandatory requirement है. अब इसी में अगर आपने I was just talking, अगर इतने लाख करोड़ आपको दे रहे हैं हाइड्रोजन के लिए, तो लोग बोलेंगे सब्सिडी कितनी है? Subsidy amount they will take and they will put a board, and after that 70% will be in their pocket and 30% will be consumed. हमें ऐसे लोगों से बचना है। और सबसे ज्यादा सब्सिडी दिल्ली वालों को तो ज्यादा पता है कि सब्सिडी क्या हो रही है। So हर चीज में सब्सिडी। अगर I was talking in one of my plants in Dadri, I said, sir हम बल्ब फ्यूज दे टाउनशिप में बल्ब दे रहे हैं, मैंने कहा सर बल्ब क्यों दे रहे हैं? पर एक आध % स्पेंड 10 रुपीज, 10 रुपए का बल्ब भी ले सकता है, नहीं एनटीपीसी में सब फ्री है। एंड दे स्टार्टेड कंजम्पशन वाज रिड्यूस्ड। सेफ्टी आइटम्स ये भी चीजें हैं। सो अनलाइक ट्रेडिशनल आइटम प्रोडक्ट मेटल रिलेवेंट फॉसिल फ्यूल्स ये सब कुछ बता चुके हैं। मेटल डजंट प्रोड्यूस कार्बन एमिशन, हमें कार्बन एमिशन से बचना है। But huge investments are required for all these plants. अब इनको सेफ्टी के साथ आगे कैसे बढ़ाएंगे? ये तो टेक्निक प्रोड्यूसिंग हाइड्रोजन यूटिलाइजेशन में रिन्यूएबल एनर्जी इज कॉल्ड ग्रीन हाइड्रोजन प्रोडक्शन। अब इम्प्लीमेंटिंग टेक्निक्स हैं, इतने बड़े एडवांस मेथड्स आ गए हैं, इतने आई वाज गोइंग टू द जर्नल्स आल्सो, आई हैव सीन हाइड्रोजन का सर्कल कल मैंने लेक्चर सुना, आई वाज रियली इम्प्रेस्ड, सो नाइसली यू प्रेजेंटेड। पर आपने बोला था कि हिंदी भी बोलना है, तो मैंने हिंदी भी बोलना शुरू कर दिया। ग्रीन हाइड्रोजन अभी को बताया, ग्रीन हाइड्रोजन है, फॉसिल फ्यूल्स है, ग्रीन हाइड्रोजन। अब उसको आप कहेंगे कि सबसे बड़ा दिक्कत है, हम लोगों ने हाइड्रोजन को बचपन से देखा है। आप याद करिए जब वो गुब्बारे में गैस बन रहा था तो उसका सिलेंडर आज मेरी नजरों के सामने इतनी थिक वॉल होती थी सर, जो गुब्बारे बेचने आते थे। तो आज के अगर हम थोड़ा रिफ्लेक्ट करें तो वहाँ इतनी मोटी चदरों के वो बने होते थे साफ सिलेंडर। अब इसको भी ह्यूज स्टोरेज करेंगे तो आपके लिए कॉस्ट ऑफ स्टोरेज विल बी टू हाई। बट आई डोंट से वी शुडंट डू इट, वी विल गो, वी शुड गो फॉर इट। आज में जाने में 75 लाख तो आपके 4 व्हीलर दिल्ली में घूम रहे हैं। I was talking one of the projects वहाँ उन्होंने देखा टनल के बीच में गए, उन्होंने मैम थी, she was EHS मैनेजर, मैंने तो मैम वहाँ तो टनल में तो आपका 0.3 आ रहा है, 0.03 CO में। कहते दुग्गल सर आप बताइए दिल्ली में कितने 4 व्हीलर चल रहे हैं, कितना एमिशन में आपको CO अलाउड है? हैव यू सीन एनीबॉडी डाइंग ऑफ CO? इतनी कार्बन मोनोऑक्साइड निकल रही है, कोई मरा हुआ देखा आपने? सो दिस इज, फिर वही आ जाएगा ग्लोबल एनवायरनमेंट है, ग्लोबल वार्मिंग है। आज सुबह पढ़ा था नवंबर में हाईएस्ट टेम्परेचर गया है इस बार दिल्ली का। ये है ग्रीन हाइड्रोजन प्रोडक्शन पाथ है, डायरेक्ट सोलर है, डायरेक्ट बायोमास है, सोलर पीवी है। I have been seeing so many projects of solar in south. इतने एरिया में 1000 एकड़ में उनके प्लांट्स बने हुए हैं, सोलर प्लांट्स हैं। और वहाँ जो उन्होंने किया है बिग जॉब। अगर उसको हाइड्रोजन से अगर आप मर्ज करेंगे, जैसे एनटीपीसी ने स्टार्ट किया है, इट्स अ गुड इनिशिएटिव, बट हाउ लॉन्ग विल इट कम? And I am sure it will continue to. Because of NTPC, I am standing here. I am proud to be an NTPC. प्लान में रह के हम काफी कुछ बोलते हैं, but once we come out and we realize here what is the importance to serve in NTPC. During commissioning green hydrogen plant, the safety engineer must ensure that सिर्फ सेफ्टी फीचर्स की बात करूंगा क्या होनी चाहिए, because lot of things are written. I want practical things which can be minimized, minimum. तो आप adopt कीजिएगा. Protocols है, thoroughly check, prevent accident. Key features क्या हैं जो check करने हैं हमें? Electrolyzer safety system, verifying the integrity of safety electrolyzer, including pressure relief valve. हम लोग क्या करते हैं? So if you ask some engineer, when did you calibrate this? क्या है? सर बेसिक चीजें लोगों को नहीं पता है। कैलिब्रेशन अगर नहीं करेंगे तो आपके अंदर का जो सिस्टम है, स्प्रिंग एक्शन है, दैट विल डिस्ट्रॉय। इलेक्ट्रिकल आइसोलेशन एंश्योर ऑल द कंपोनेंट्स आर सेपरेटेड, मॉनिटरिंग सिस्टम कंफर्मिंग टू सेंसर फॉर टेंपरेचर प्रेशर। जितना आपने सिस्टम इंस्टॉल किया है, इज इट वर्किंग? एक्सीडेंट होने के दो रीजन है सर, either we shortcut it or bypass it. अब आपने सिस्टम बना दिया, अरे वो सिस्टम अरे बाईपास कर दो, अरे सर वो नहीं हुआ, शॉर्टकट कर दो। यही तो एक रीजन है। जब हम एक्सीडेंट की बात करते हैं तो काम करवाने वाले का गलत तरीका होगा तो एक्सीडेंट होगा, काम करने वाले का तरीका गलत होगा तो एक्सीडेंट होगा। Either you are forcing the workers to work in unsafe condition, or you are just acting on workers' belief is unsafe, because you are worried about production. You are worried about generation. At what cost? एक एक्सीडेंट होता है 4 दिन काम बंद हो जाता है। अगर आप 10 आधा घंटा लगा के उसको सेफ्टी से करवाएंगे, that will serve your 4 days. Monitoring, everything is in place, सब कुछ लगा है, documents बने, everything. But where we are going for monitoring? Monitoring system is a little bit to be taken care of. Not safe area, it has to be taken care.
Actually, now all the monitoring system has to be on the digital platform, where one need not intervene. For all type of monitoring, it is not specific to
So this is the online जितना हो गया है, जितना आपका permit system issue online है, that's some people rather than on papers. And when I was doing some investigation, यार वो paper तो मिल नहीं रहा जो permit issue किया था. Now online everything is clear. So monitoring आपकी automatically हो ही रही है. Hydrogen detectors हैं, ensure installation of functionally all critical areas such as production unit, storage area, piping system and leak को detect करना ही is a big problem. अगर आप leak detect initial stage में कर लेंगे, you will prevent accident. अगर नहीं कर पाएंगे तो ventilation system, verify the ventilation system are adequate and diverse hydrogen in case of leaks. Emergency shutdown. Emergency shutdown भी होना procedure जो है कैसे की है system prompt activation. अभी recently I remember when I was in the gas plant Dadri, the system this fire system, this extinguishing system, flooding system, carbon dioxide, it was not kept in manual. I insisted for auto. It was in auto, and suddenly there was a fire and it was immediately extinguished. तो वहाँ ये सिस्टम जो वास्तव में है वास्तव में ही रहने चाहिए। लोग कहते हैं कि बात थोड़ा बाल फंक्शनिंग होगा, अलार्म बजना शुरू हो जाएगा। अब सेफ्टी की बातें करते हैं सर, ये बाहर जो काम चल रहा है इट्स 100% अनसेफ, ना जूते हैं ना हेलमेट है ना कुछ, तो पर्सन इज वर्किंग। व्हाट विल पीपल लर्न फ्रॉम कि सेफ्टी की बातें हम करते हैं। Piping integrity, inspect all hydrogen pipelines, connection and proper installation, sealing and absence of leaks, pressure relief valves है, manual automatic valves है, जितना है इनकी functioning जो है, कई बार हम इसी में थोड़ा मार खा जाते हैं, bypass कर लेते हैं। Sir please, इतने सीनियर लोग बैठे हैं, यंगस्टर भी बैठे हैं जिन्होंने कल प्लांट में जाके काम करना है, never compromise with safety, safety is a habit। आपको सेफ्टी कोई प्लान में जाएंगे पढ़ाएगा नहीं, बताएगा नहीं, सिंपली एज ए टेक कोवर्कर्स एंड यू आर एन इंजीनियर, यू डू दिस जॉब। स्टोरेज टैंक सेफ्टी, इंस्पेक्ट हाइड्रोजन स्टोरेज टैंक्स फॉर प्रॉपर मटेरियल कंस्ट्रक्शन स्टैंडर्ड्स एंड प्रेशर। हर चीज आपके पास स्टैंडर्ड्स आते हैं, यू हैव टू कंपेयर इट, देन यू हैव टू फाइनलाइज इट, देन इंप्रूव इट। कूलिंग सिस्टम आपका प्रॉपर होना चाहिए, सेफ्टी डिस्टेंसेस शुड बी क्लियर। Fire suppression system is most important thing is in a station in fire suppression system. अगर आपका fire suppression system काम नहीं कर रहा है, we are spending 10% of the cost of this project cost 10% is on fire system. अब लोग बोलते हैं fire system या फिर बंद कर दो ना, आपकी क्या जरूरत है? So these are minor things, explosion proof equipment है, सर ने बहुत अच्छा बोला। Flame proof lighting लगी अंदर मच्छर मर गए। How is it possible? या तो I will check up sir, excuse me I will check, क्योंकि flame proof light में आपने कहा मच्छर कैसे मरे हैं, that's a big issue। I at least मेरे को थोड़ा मन नहीं मान रहा है, I will see to it। Explosion proof equipment flame arresters हैं, check installation of flame arresters। कितना स्टैटिक चार्ज डेवलप हो जाता है वहाँ, एकदम से लोगों को कईयों को पूछते हैं स्टैटिक चार्ज हाउ ही डेवलप। अब जो इंजीनियर आए पीडीडीसी में, मैंने कहा स्टैटिक चार्ज सर लर्न ऑफ इट, हर्ड ऑफ इट। अब मैं कहा यार पुराने जमाने में लकड़ी घिस के क्या करते थे, फ्रिक्शन, आग लगती थी कि नहीं? हम मूव कर रहे हैं, रबर है, फ्रिक्शन से पैदा हो रहा है, चार्ज हो रहा है, सामने एकदम से तो आग लगती नहीं है, पहले सुलगती है, फिर टेम्परेचर आता है, फिर फ्लेम बनती है, देन इट कैचेस फायर। इमरजेंसी रिस्पांस प्रिपेयर्डनेस, दैट्स वेरी इंपॉर्टेंट। लोगों को सबको पता होता है कि इमरजेंसी रिस्पांस क्या है। वी ऑलवेज गो फॉर मॉक ड्रिल, दिस इज स्टैंडर्ड।
Sir, may I request you to conclude?
Okay. Emergency equipment, emergency communications, personal protective equipment, these are everybody knows, last resort है, once you just substitute करिए या eliminate हो सकता है, eliminate substitute करिए, otherwise last resort में इसको दे। Training and drill, training should not be for the name sake training। Training में लोग जाते हैं, बुरा मत मानना, क्या मिलेगा यार 10 रुपए का पे? अरे ट्रेनिंग में जाओगे, you will learn something out of इतने स्पीकर्स आए हैं, at least मैं ये कह सकता हूँ कि 60 to 70% I have learned from you people. At my age is, I think, I mean next to him, age learning की age कोई खत्म नहीं होती है, जितना है आप कर लीजिए। सेफ्टी प्रोसीजर एंड मैनुअल, सबके मैनुअल बने हुए हैं, सब आपके प्रोसीजर बने हुए हैं, लेड डाउन प्रोसीजर है, पेस्टेड है, बट alarm management, thoroughly checking the safety features during the commissioning of green hydrant. A safety engineer can ensure that plant is safe, compliant. Safety वाले को बोलते हैं तो साइन करते हैं प्रोटोकॉल में, everything has been done. The once we sign, everything is.
तो जड़ी इसको चेक करके जरूर करके
ये आपकी स्टोरेज है, हाइड्रोजन सिलेंडर जितने भी आएंगे सर प्लीज फॉर गॉड से जाके चेक करिए, उनके ऊपर वॉल कैप नहीं होगी। 80% I am sure no won't care. और जरा सा unloading procedure is नीचे टायर होगा. This is after technician, dangerous. This is after stasis. ये after storage. NTPC कवास मैं तो नहीं रहूँगा सर, आपने तो बहुत आगे बढ़ा दिया. So I move on. Any questions?
सर आपने बोला ग्रेड कोड इलेक्ट्रिकल लोड मच्छर
कैसे आ गए? मैं वही पूछ रहा हूँ.
मच्छर जाए सकता बिकॉज़ बॉडी बोथ ग्रेड कोड इलेक्ट्रिकल बॉडी एंड फ्रेंच इज a gap of 5 mm. So मच्छर cannot be entered. So if gap is more, means they are not caring for the safety.
Sir, I can't share the name because you and me and both are auditing, so I can't share the name of the client. But actually, in focus on that, how did the frequency of pain through? If the insects are inside, how can you say this? Are you claiming that
देखिए सर, ये देखिए ये चीजें बड़ी एक्सपीरियंस है. अब इस टाइम अगर मैं अपना एक्सपीरियंस बताऊंगा तो कहीं से एज भी नहीं होगी. I retired in 2007 at the age of 16. So कहने का मतलब है कि everything is in your hand. There would be engineers, would be जो coming generation है, they have to take care. सर आज की डेट में आप ये देख लीजिए कि बच्चे भी 1 से 2 नहीं होते हैं. अगर उसी को कुछ हो जाता है तो what will happen to the parents? तो बच्चों को भी एजुकेट करना है about safety. It's a habit. मैनेजमेंट के कहते हैं हमारा ये सेफ्टी इज कल्चर विद अस. But how much you are implementing, how you are enforcing, that's the will of the top management, not the bottom. Thank you.
Thank you so much, sir.
मैं तो सोच रहा था मैं बताऊंगा कि सब तो आप लोगों ने बता ही दिया.
Thank you, sir.
Thank you, sir.
Now the next presenter is Mr. Jayant Sinha, who will be talking about the challenges and innovations in green hydrogen, a pathway to sustainable energy transition. Ten minutes for presentation.
Good afternoon to you all. My name is Jayant Sinha. I am an engineering graduate from BITS Pilani and then later went on to do my leadership course in sustainability management from Cambridge University, UK. I have served with a lot of my IPEC colleagues are there, and subsequently I went abroad to work on energy transition. Right. So my presentation would be slightly different because I would be focusing more on how you are introducing technologies and what are the challenges you face during production, storage, and applications as well. And so this will be very interesting also because these are something which is also related to implementing safety across the entire hydrogen production and supply and storage value chain. This is a potential energy resource of the future. We have talked about hydrogen not only being applied in cogeneration in electricity but also for various industrial applications. And apart from that, hydrogen we have also introduced in Leh. The green hydrogen buses are there, and also in Delhi also last year some green hydrogen buses were flagged off by Indian Oil Corporation. So ultimately the idea is that how we are going to achieve, how we are going to combat climate change, and how we are achieving the net zero ambitions of the government. We have to achieve net zero by 2070, but the process has already begun. The fossil fuel based generation will be gradually be phased out, but still it will be there for some time, because when we are talking about energy transition, we also have to talk about energy affordability and energy security as well, right? The innovations, lot of innovations have already been tried out in green hydrogen, and some of the major innovations, because green hydrogen production essentially comes from electrolysis of water, which is the cleanest method of green hydrogen, which I will be talking about, and it is one of the most promising vectors of energy transition. So these are the different aspects where hydrogen is being used to propel our economy. This is not just the power generation that we are talking about, but also industry feedstock, transportation, and heating. You can interrupt me if you have any question during my flow also, I don't mind. But there are huge challenges. Some challenges have already been discussed, and these challenges are regarding the creation of the hydrogen infrastructure itself, the storage infrastructure, which needs cryogenic conditions to maintain hydrogen in that state where it can be transported or it can be stored, because it is highly flammable gas. And you must have also noticed that there are green hydrogen policy. Because I come from a company, Interest Power, who are supporting the government as well, and also the different industries in the policy formulation and also mainly implementation. How these the policies can be implemented as per the green objectives, the net zero ambitions. So the tracking is also equally important in terms of energy efficiency tracking as well as the carbon footprint tracking. So also helping the academia to prepare all the different course materials, because whenever the new graduates come to work, they should be aware of all these aspects. So helping some universities also to prepare all those different course curriculum so that they are compatible with the energy transition requirements of the industry. So different production technology, they are all pros and cons. So there is no easy dispensation here. So proton exchange membrane is the most common. It has got high efficiency in production, but initial production costs are very high. The reason being is the cost of the electrodes or of the electrolyzers, and also the local manufacturing capability. So as and when we are able to have better capability of producing enough electrolyzer, the process has already begun. Some few companies in India have already started manufacturing, and there is a goal that we should have enough capability of indigenous production of green hydrogen up to 5 million metric tons by 2030. So that means that we need to have indigenization of electrolyzers also, so that we can bring the cost of hydrogen down. Apart from that, there are other methods, alkaline water electrolysis, which essentially will be using sodium hydroxide and potassium hydroxide for splitting of water molecules into hydrogen. Then solid oxide electrolysis cell. So these have again high efficiency, but it also requires high operating temperatures, and there are material challenges also. So cost of material, where you are sourcing the material, when you are producing green hydrogen, we also have to ensure the complete traceability, where the material is coming from. For example, if you are talking about green hydrogen and the material that you are bringing in, it is coming through transportation, which are through fossil fuels, then you are already generating scope 2 emissions. So those kind of things are important, where we should be tracing right from the source right up to the production. Also, if it is possible to see how it is being used, so that least carbon dioxide emissions are there. So we are talking not just of scope 1 emissions, but also for scope 2 and scope 3 emissions. So green hydrogen will definitely, when you are producing or when you are using, you are not generating any oxygen, but carbon dioxide. You are not emitting any carbon dioxide, but when you are, the way you have to trace across the supply chain, you also have to ensure that no carbon emissions are being generated. So photoelectrical chemical water splitting is also which utilizes solar energy, but it has got poor efficiency, so it is not something of economic interest at this point of time. Biological and microbial electrolysis is sustainable, which uses organic waste. Some presentations have already been there. The cons are that it has got low production rates. I'm going slightly fast because I've got so much material to share. and I also have to give some time for the question and answers. So green hydrogen storage and transportation, one of the main, you have to compress that hydrogen if it has to be transported and stored also at 700 bars. So 700 bars means the size of the tanks and also the thickness of the wall will also be very heavy. So that is how it is stored. So this adds to the cost as well for compressed gas storage. Then liquid hydrogen storage, again, it would need creating of cryogenic infrastructure. So something like minus 253 degrees centigrade. You can understand how much low is the temperature for liquefaction of hydrogen. And then subsequently, it can also be done through metal hydrides. So it can be absorbed and then it can again be released. But it again, the cost is an important consideration here, and a high temperature needs to be generated in order to get back hydrogen from the metal hydrides. Then chemical storage is one of the common way where you can convert hydrogen into ammonia, and then it can be transported, and then it can be converted back into hydrogen. And this is one of the things which is very viable, because if it is converted to ammonia, it can also be utilized by the ammonia plants for production of green urea or the green fertilizers, which is also a sustainable fertilizer. And then the underground storage is in caverns, in depleted oil and gas fields. So large scale storage capacity is required for this thing. It requires suitable geological formations also in order to store this thing. Right? So you will notice that still hydrogen, it is I told you it is the energy resource of the future, because it has got high gravimetric energy density, one of the highest, which you will say close to between 30 to 35 kilowatt hour per kg. That is the kind of electricity that could be generated from hydrogen. So high energy density. So coming to how innovatively we can use hydrogen fuel cells for running on the buses and all, and also for industrial application to produce electricity, because we have got this hydrogen fuel cells, and it can be used sustainable transport, sea, land, and air. Then renewable hydrogen, once renewable energy sources that we use for powering the electrolyzer will obviously have less carbon emissions or no real carbon emissions. And then these green hydrogen can be converted into a lot of industrial intermediates, a lot of other hydrocarbons which can be used, and also hydrogen is being used in NTPC as well. Something around 5% hydrogen is being blended with natural gas to reduce the carbon emissions. So these are different aspects. Then apart from that, there are cogeneration, where combined heat and power, where I've talked about blending, and then definitely the hydrogen propulsion, which can be used in transportation application. And technology is going to play a very important role here. I will talk of 4 technologies here. One is artificial intelligence, machine learning. These AI/ML technology is being used for optimizing production, optimizing doing the predictive maintenance also, and also optimizing the RE resources. We have been successfully carrying out a lot of projects in which artificial intelligence have been used in order to monitor the electrolyzers, monitor the RE resources, and also ensure how much is the optimum production capacity based on the real-time electricity demand, based on the availability of the renewable energy resources. So then Internet of Things, I think already Mr. Vikas Kumar, I think you have mentioned about the sensors, the role of sensors and telemetry, because when you are operating this electrolyzers and also the renewable energy, we need to have the monitor all the weather parameters, the temperature, pressure, as well as if you are operating the electrolyzers, then you have to monitor the condition of the membrane, so and also the temperature of the water for splitting of the water into hydrogen. So these are some of the things where sensors and telemetry are going to play an important role. At sensors already the prices are reducing, so this can also be a factor how we can implement Internet of Things to actually not only ensure safety but also help in improving the efficiency or also probably reducing the cost. So a lot of decisions are also taken based on the data that is generated from the sensors. Then I talked about certain things like certificate of origin is very important if you are actually buying green hydrogen. But you have to see that if you are buying the green hydrogen, then it has to be certified. So we use certain technologies, to ensure that like blockchain. Blockchain is an electronic ledgering system. The ledger system that we use, it's a completely paperless, where you use advanced encryption technologies and also in order to secure and do energy trading also, because there are some price involved when you are trading in hydrogen, and also the electricity prices in real time. So this provides a complete transparent method. So that is the blockchain technology, which you will learn more about. And district twins are something where we try to remotely monitor. This we have successfully used, particularly during COVID times when you can't personally visit all these plants which are all remote, because we are not only visiting the installations where all the solar or wind power stations are there, but also the electrolyzers and different other equipments. So district twins are the virtual replica of the actual system, so remotely you can monitor, and then accordingly you can do the modeling and simulation, and then you can also use for designing of the electrolyzers, designing of the wind farms and solar to produce that capacity that you need. And of course the advanced analytics, which would mean the data that is being produced through various means. I mentioned about the sensors and the telemetry. So these sensors, whichever you have got so much of data that has to be interpreted, and then suitable decisions have to be taken regarding planning and optimization of the hydrogen production, how much has to be stored, because that decision will also directly impact on your cost of safety. So you have to ensure that you are producing in the optimum capacity, where you are not only optimizing the cost of production, you are also optimizing the cost of pipelining and transportation, you are also optimizing the cost of safety, so that it can be made available to the end users affordable, right? So all these things are important. Business intelligence, we use a lot of business intelligence through the data. So with this, I come to the end of my presentation, and I have exactly taken 10 minutes. Thank you.
Of hydrogen in the storage for the storage tank, what is the material of substation?
Sir, actually,
you see, hydrogen with some metals is embedded, and that leads to
sir, first of all, the hydrogen is very reactive. So the hydrogen is very reactive. So yeah, very reactive. So these are special alloys which are used. I don't know the name of the alloy because that is not my area. But we use specialized alloy which are inert to reaction. So we use special metallic alloys which are inert to any hydrogen reaction, so that it can be stored without any deterioration in the purity of the hydrogen.
ये बड़ा रिएक्टिव है, बड़ा डेंजरस है। हाँ, तो मुझे भी लीकेज हो गया तो ना हो गया।
Yeah. So we are preparing a lot of course material on this aspect. This someone else.
How can artificial intelligence be used to increase green hydrogen production and improve safety?
Right. So yeah, so this is a very good question, because I'm asked this in many of these conferences that I present on green hydrogen. See, for green hydrogen production, I'm talking about the green hydrogen. You are using electrolyzers, and to power electrolyzers, you are using the wind energy or the solar energy. Even biomass is being used. So what happens is that when you have so many of data, and you have to take a decision in real time, because hydrogen is something which has to be produced optimally, because it is a costly way of producing. So what we need is human interpretation will take time. So what we do is that artificial intelligence and machine learning, we train the algorithms based on certain parameters. That we know the parameters, we will let the machine think the actions which we want them to take. So these artificial intelligence algorithms are fed with a lot of data regarding the availability of the cloud cover, which might affect performance of the solar panel, or availability of the wind or wind speed, which might affect. So apart from that, also the condition of and what are the energy prices. Because when the energy prices will also have an impact on the green hydrogen cost of the green hydrogen. So if all these parameters are then fed into that AIML model, then the model will do it for you. Just like we do it offline using Excel sheet, we give all the parameters and it will do it. But that is offline process. But online in real time, we get all these real time data. The AIML model will give you the same decisions, and it is almost 95% accurate. So that you can confidently say that using this AIML, we should be producing this much of hydrogen, and to also taking into account your consideration also safety. Because we are optimizing the production, and by optimizing the production, we are ensuring safety, and we are also helping in the cost.
Thank you so much, sir. Now we have the third paper in the row, which would be presented by engineer R.R. Tannaji, and the topic is case study NTPC's green ethanol synthesis project in India. Please, sir.
Thank you. I am R.R. Tannaji. I retired as General Manager from Delhi Hydropower Corporation. And Mr. Goyalji, Mr. Dugalji, and so we are all from power sector. Dugalji, he was with me, he was in Central Electricity Authority when we joined Central Water Power Commission. So we are all from power sector. Now GHAZIABAD has already entered thermal also. We are making project 1320 megawatt thermal power plant, and in all wind, solar, everywhere, this Delhi has entered, and in all generation, all type of generation we have already entered. So the case study was not prepared by me only directly, because we are also working on the thermal. So Mr. K.C. Nirula has helped me. He is my colleague, and we joined together Central Water Power Commission. Mr. K.C. Nirula, he is on the way, he is also coming. I requested him. In my career, I have done 5 projects total. First, I joined local hydropower plant in Manipur, where Mr. Dugar has spoken about safety. That safety I have never seen in India. That local safety, biggest safety we have seen, we have been taken from Dhanbad mining station, under central mining station. We have seen the safety mining. Safety big chapter, we will not speak more on safety. Regarding this case study, the ethanol project in NTPC, because we are also engaged in TAGC is also engaged in the sector. I requested Raghunaji kindly make this thing, and he has helped me for preparing this case study. He has directly helped me for the NTPC case studies. So actually, I forgot my pen drive, and I have this hard copy with me. I will go through point to point. Objective of the green method of NTPC: reducing carbon emission by producing methanol from the renewable hydrogen. All speakers have already spoken. I will not go in detail. Utilizing captured CO2, carbon dioxide, creating sustainable methanol supply. These are the topics. There are the details. I will not go in the details. These are I am talking about the main heading only, sir. Key components of NTPC green methanol projects. NTPC green methanol projects integrate several components combining CO2 capture technology, renewable hydrogen production, and methanol synthesis. Renewable hydrogen production, CO2 capture utilization, methanol synthesis technology, catalytic reaction, environmental and electronic benefit,
because these are connected with the hydro as well as with the thermal also. That's why we have shared this case study. Emission reduction also. Energy stored is also combined with NTPC as well as thermal as well as hydro, and in any industrial projects also. Support for renewable energy integration. This is also same thing, sir. Economic potential and method of economy. Green methanol has significant economic potential, providing new revenue stream for NTPC and other projects, creating opportunity for employment in the green energy sector as the market demand for low carbon fuel increasing. Green methanol can become a profitable product for India's domestic and export market. This factor is applicable it may be in any industry project, like because in Nalco project I have worked 5 years in Odisha, that was a Nalco cement plant. I have worked there. There was hydrogen and all, ethanol also used there. Challenges from NTPC green methanol projects is there. These are the points are given: high production cost, technology readiness. Infrastructure requirement are the same for the hydro. It may be any projects in thermal or hydro or any wind or any. Policy and regulatory support is also same thing for hydro or thermal. Impact and future prospect of NTPC green methanol project. Yes, the NTPC green methanol project has promising implication for India's energy and infrastructure development. Clean fuel alternative and transportation and shipping. This speaker has already spoken about it, sir. Supporting India's national hydrogen and clean energy goal. This Mr. GHAZIABAD also has spoken on this topic. Electrolysis. NTPC electrolysis technology to produce hydrogen and separating water molecules into hydrogen and oxygen. CO2 capture and utilization. This already covered. Carbon capture. Methanol synthesis technology. Methanol synthesis technology involves catalyzing a reaction between hydrogen in a controlled environment. Catalytic reaction using a catalyst and hydrogen CO2 react at high temperature and pressure to produce methanol. Environmental and economic benefit. What are the benefits? NTPC Green Methanol Project offers several environmental and economic advantages, enhancing India's move toward cleaner fuel and reducing the environmental footprint of traditional fuel production. Emission, already spoken, sir. Energy security, I think Gugalji has spoken. Gugalji has also brought this point. Support for renewable energy integration. Support for renewable energy integration. The project promotes the use of renewable energy as renewable powered electrolysis for the hydrogen production, integrates solar and wind energy into industrial sector. To contribute to the stabilization of renewable energy demand and support India's renewable energy sector. Economic potential and methanol economy. Challenges faced in NTPC green methanol project. These are challenges critically I am telling you. The green methanol project presents several challenges that NTPC is addressing through innovation and investment and strategic planning. High production cost, technology readiness, infrastructure requirements, policy and regulatory support, impact and future prospect of NTPC green methanol project. Clean fuel alternative and transportation and shipping, supporting India's national hydrogen and clean energy goal. These are already covered. creating a model for other green methanol projects. Recommendation of scale green methanol production. To scale up green methanol production and increase its adoption in India, the following strategic recommendations are: investing in R&D, research and development, expanding renewable energy infrastructure, government initiative and policy support, public-private partnership, PPP. The conclusion of all this report is NTPC Green Methanol Systems project represents a significant step toward sustainable fuel production in India by leveraging renewable hydrogen captured CO2. The project contribute to emission reduction, supports India's national hydrogen mission, and sets a precedent for the industrial application of the green methanol. While challenges such as high cost and infrastructure requirement remain, NTPC project illustrates the potential for green methanol to decarbonize India's chemical and energy sector. With the right combination of the technology, innovation, policy support, and partnership, green methanol could become a cornerstone of India's clean energy transition and contribute to a sustainable, low carbon future. Thank you.
If there are any questions from your side, you are welcome to ask.
अपने हमको लिखने का हम पूरी एक बार बुला लेते हैं इसको आपके साथ के आए
अरे गुरुला जी
हाँ
आगे हाँ मिस्टर रुला है with the help of K.C. Nurullah, my son K.C. Nurullah joined Central Water Corp Commission both a while. I don't study. पहले पढ़ले थे ये मेरे जैसे थे so he has helped me for prepare this report and because I have already told that NTPC
basically is how to capture carbon dioxide from because you see you gas and what comes here is of nitrogen carbon dioxide some compounds are also there so it's कैसे कैसे plant में
एक्चुअल में क्या है CO2 we are capturing through this तो आपका बेसिकली क्या होता है जहाँ पर आपका ये चिमनी रहता है बेसिकली उस चिमनी से नीचे से ब्लू गैस निकलती है वहाँ से CO2 कैप्चर करते हैं हाँ जी तो वहाँ से CO2 कैप्चर होती है then we are mixing with the hydrogen
नहीं how उसे कैसे कार्बन डाइऑक्साइड कैसे उसे how to extract carbon dioxide from flue gases by scrubbing is one of it
वो उसको सेपरेट भी करते हैं उसको बेसिकली वो उसका सिस्टम लगा हुआ है और उसको निकाल के उसमें से CO2 को अलग कर देते हैं CO2 को
scrubbing is one of the
This CO2 is happening.
mixture of gases का flue gas and flue gas is a mixture of this carbon dioxide is one of the carbon monoxide is there and nitrogen is there
And nitrogen oxide here. Project A policy says CO2 is separate.
Let me share whatever I know. This project is on the experimental basis. We have put this project at Inderprastha, where our target is 10 TPD, 10 tons per day. इसमें क्या जैसे आपने कहा है CO2 and other gases हैं. Other gases का filtration करते हैं और कुछ gases को absorb करते हैं. Absorb कराते हैं. अब इस गैस के लिए कौन सा absorption material है वो I will let you know ऑपरेट ध्यान देंगे. पर लेकिन उसमें absorption टेक्नोलॉजी यूज करते हैं.
पहले प्रोजेक्ट अभी
First flue gas has to be CO2 has to be separate it from.
Yeah, yes.
Then only you can make this
Plus, you want to basically, you take it.
Then only we can make them allowed.
Then only it is. Yeah, it is right.
ये सर्वर के लिए एचडी यूज करते हैं आपको सेम टाइप के रहते हैं एचडी आजकल दूसरा टेक्नोलॉजी चल रहा है सर्वर है सिमिलर
एफडी फैन जो होता है एफडी फैन के
हां वही तो एफडी डेटा का आउटपुट है उसका भी हिट कर रहा है मतलब बेसिकली टैब लगाते हैं बिफोर गोइंग टू चेक
Now I think we can go for a lunch, and after that remaining papers of this session will be continued. Thank you very much. So now we are switching for the lunch. Thank you very
सर वैलिडिटी आप करेंगे हमारा तो फ्री हो गया इफ यू वांट वो एक बार लंच करते हैं उसके बाद दो पेपर छोटे से इनमें से शायद ही कभी नहीं आए हैं आप अगर चाहें लंच कुछ that's at हो सकता है कम हो